a lot of people, what they try to do, so ignore this is not what we're trying to do, but I think most people think this is asking us to do the following. Just remove the parentheses, and that's it. And now combine like terms. So people think that this just really means remove the parentheses, that this is just a negative 3x plus 4, and that now you would combine like terms. But this is actually not what it means. What this actually means is take the expression 3x plus 6. For that we can remove the parentheses because if we remember from order of operations, there's nothing that we're waiting for. In other words, there's nothing being to be distributed into the parentheses. What this actually means is subtract the following things. So subtract all of this. So that means subtract 3x and, whoops, I'm actually writing and subtract negative 4. That's what the implication is. So subtract everything that's in the parentheses from this expression right here. So subtract 3x and subtract 4. And that's exactly what we're doing here. So let's see, let's figure this out. So I have 3 copies of x. I'm taking away 3 copies of x. That means I don't have any copies of x. I have 0x. If you want, you can write that down, but 0x is 0. 0 times anything is 0. So 6 minus 4 is positive 2, and so really this just ends up being the constant 2. So whereas we thought we had all these variables, it just is always going to work out to be positive 2. And you can test that out. If I put in, let's say 7 for x, I'm just picking a random number, I get 21 plus 6, which is 33. Oh, not even close. 21 plus 6 is 27. Minus 3 times 7 is 21 plus 4 is 25. 27 minus 25 is 2, and that's exactly what we get. So this wouldn't give us the same answer. This would get 3 times 7 is 21, plus 6 is 27, minus 21 would give us 6, plus 4 would give us 10, and that's not the same thing that we get here, or here. So that's basically what this is saying. Alternatively, some people like to think about it this way, and you can pick which flavor you like the best. They think about it as, well, I'm really adding negative 1 copy of 3x plus 4. And they treat this as the distributive property over here, and they think, okay, well, that's negative 1 times negative 1 copies of 3x is negative 3x. Negative 1 copy of 4 is negative 4, and now they get the same thing they would by thinking about it conceptually. I prefer the conceptual point of view because this tells me subtract away everything that's in the parentheses. Then I never have to worry about, do I turn the pluses into minuses, the minuses into pluses? I just let the logic have me follow things through. Okay, so we're also going to mention some, before we do this idea of foiling, we'll do some working with exponents type stuff. So a lot of people get confused by these types of things. So exponents, working with properties of exponents. So x to the third times x to the fourth. Well, a lot of people learn rules. You probably learned rules where do I add the exponents, I multiply the exponents. Well, by definition, 3 squared means 3 times 3. 4 squared means 4 times 4. 3 to the third power means 3 times 3 times 3. So the exponent tells us how many times we multiply by itself, 3 copies. Here I'll have 2 copies multiplied. Here I'll have 2 copies multiplied. Well, so that means the same thing here. So let me write this out piece by piece. So x to the third means x times x times x. X to the fourth means x times x times x times x. Order of multiplication doesn't matter because we know that 2 times 5, for example, is 10, and so is 5 times 2. So the order in which I multiply doesn't matter, point being that really I have x multiplied by itself 7 times right here. So I have x to the 7th power. I will kind of condense that down into just one lump sum. So similarly, if I had x to the 2nd times x to the 3rd, I would have x times x times x times x times x. Well, I have x multiplied by itself 5 times, so that's x to the 5th. And most people will see by now